Good afternoon. Today I'm gonna tell you about the bias-dependent behavior. And the first is the summer equilibrium situation, and second is the forward bias, and third is reverse bias. And I'm gonna tell you about the recom generation and recombination and band-to-band tunneling. Okay, let's start. Today, I will use my iPad. So now I feel very excited. Okay, the first is the summer equilibrium situation. As y- as you can see in this show slide, here is some electron distribution, Boltzmann-Taylor distribution, and here is some whole Boltzmann-Taylor whole distribution. And in the thermal equilibrium situation, the junction potential is so high, so the barrier is very highly. So the electron in n n side can't move to p side because the barrier, and only little carrier can move to p side, but on p side already have the little electron. And also about the hole, here is some barrier. So the hole can't move to inside. And also on inside, here there is some little hole concentration. You have to know about this equilibrium situation diagram, basically. And and at when the fault bias, the the diagram will be like this. The junction potential will be lower. Okay, we can see next slide. Okay, this situation is for bias. As already I mentioned, the diagram looks like this. The junction potential is lower than equilibrium situation. So the also barrier is lower. So the excess carrier about the whole electron can move to p side. And and also the whole concentration excess carrier can move to n side. So when the hole moved here, looks like there is some electron concentration when equilibrium situation. So the difference between this concentration and this concentration, there will be some diffusion. So in so we can notice in this area there will be diffusion current. And also about the hole in this area, there will be also have the concentration diffraction between this and this. So here will be also diffusion. We have to know the diffusion current. There is the diffusion in the forward bias, and the electron and hole can move to another space. And next, I'm gonna tell you about the generation and recombination. Generation and recombination is opposite process, and it is stimulus behavior. Okay, when the reverse, as you can see this slide, here is some reverse bias. Okay, now I will tell you about the generation first. When the electron in here and the energy come from outside to this electron will be excitation and move to upward. And similarly, here this area, this electron will be hole. We can call this process is generation. And after this electron release the energy to outside, the electron will be go down and combine with this hole. So the hole and because by the EHP, electric and hole pair, this will be go another way and release something light or small energy. So we can call this process is recombination. I already mentioned the generation and recombination is the opposite process and stimulus behavior. You, we can know, we can have to know this is the opposite process, and the opposite process is the invertons. And next, um, I will tell you about the band to band tunneling, aka PTBT, when the levers bias highly, very, very heavily. There is some minus plus. The the slope in depletion area will be like this exponentially go upward, and at this this like when this time here the slope is very highly like exponentially highly. The between this and this gap will be closer. And at the time up from about the quantum tunneling caused by quantum tunneling, the electron can move here and here because this gap is very, very closer and very, very tightly. So the electron can move to here. We can call this BT band tunneling, and we can draw this situation using IV curve. So let's draw the IV curve about band to band tunneling. And we can call this is Jenner tunneling. Okay. Here, so the y-axis is the current and x-axis is voltage. Okay, as you know, the here is the forward bias, and here the left side is the reverse bias. And you maybe already know in the forward bias, the current will be increased exponentially with the voltage, and the reverse bias, the current is not exist, and sometimes like this. Here is this avalanche point and multiplication. And this general tunneling curve looks like this. Here is the general tunneling. It looks like very simple, but if you want to draw this general general tunneling curve, you have to know about these contents. Okay, thank you for watching this video.